students, so in this video we're going to be talking about geometric series. And I just wanted to talk about real quick the difference between a sequence and a series. So for this example in your book, you have some terms that are written in here. They're being added though. These terms that are written in here are part of a sequence, but when you add them, then that sum is called a series. Okay, and we talked about in the last video that we had, arithmetic series and sequences. This is actually geometric because when you have one term, you have to multiply it by something to get the next term, and multiply that by that same number to get the next term. So that's a geometric sequence, and then when you add them all together, that's called a geometric series. So I just wanted to clarify that. We're going to actually be using a formula that's going to be the sum of the first n terms of a geometric series, and that formula is S sub n, and then it's the first term times 1 minus r to the nth power all over 1 minus r. So we're going to be using this formula when we do our next couple of problems here. So in example 5 in your book, it says find the sum of the finite geometric series. And here is our series. And so what we want to do is we want to figure out, okay, well, what's a sub 1, what's r, and what's n? We can kind of see a sub 1 again is the first term. So we can see that a sub 1 is equal to 1/3. So that one's pretty easy to see. R you can find by dividing one term by its previous term. So if you do that, 1/9 divided by 1/3, that will actually help you find R. You can also kind of see it, what's being multiplied, but this will just show you for sure what it is. You can tell they multiply by 1 each time, and then on the bottom they multiply by 3. So it should be 1/3. But this is nice to just see what it is. So 1/9, remember, keep, change, flip. So I'm keeping this top one, changing this, and then flipping this one, and I get 3/9, which reduces to 1/3. So that confirms that. And then I need to find the number of terms. And so right here, you can't really see the number of terms. So what we're going to do is use our previous formula that we had on the previous video, part 1, that a sub n equals a sub 1 times r to the n minus 1. So we're using that formula to help us find the number of terms. For the a sub n, we're going to use the last term. We want to know how many terms we have, so let's use the last term. So that's 1 over 729. That's the last term. Equals, the first term is 1/3. And then we do have r now. We have r is equal to 1/3. So I'm going to put that in parentheses and say 1/3 to the n minus 1. I know this looks a little complicated, but hopefully not all the examples that you do, all the work that you do will be this difficult, working with fractions, but this is a little bit more of a complicated one because it's got fractions. But what you would want to do to solve this is start by dividing both sides by this term right here. Or you can think multiply by the reciprocal. If I were to multiply by the reciprocal of 1/3, it would be 3. I'd be multiplying both sides by 3. And by doing that, I'm going to be getting rid of this 1/3. So now I have 3 over 729 equal to 1/3 to the n minus 1. Okay. And now what I need to do is rewrite this bottom term. And what I want to do is make this a power of, first I probably want to reduce this thing. So 729 divided by 3 is 243. Let's reduce this first. So this is 1 over 243 equal to 1/3 to the n minus 1. And then I can rewrite this to be a power of 3. So you'll probably want to do that on these. I noticed in your book it's definitely going to recommend that you do that. So 243, let's see what power of 3 that is. If we were to raise it, let's say to the, oh well, I just did that, 5th power, I get 243. So this is 1 over 3 to the 5th power equal to 1/3 raised to the n minus 1. Okay, so now we're getting somewhere here. Now there is an interesting thing that you can do here. You can actually, let's rewrite this as 1 over 3 to the 5th power. Let's do that as well. And that way it's written a little bit better for you to see. Once you have the same base for both of them, notice I have 1/3 as the base for both of them. Once you have the same base, you can actually set the exponents equal to each other and solve for the number of terms. And so when I do that, n minus 1 equals 5, or you can say 5 equals n minus 1. And then you add 1 to both sides and you get n equals 6. So now I know in this sequence or series, I have 6 terms. I have 6 things that I'm adding together. So what I want to do then is I want to now use my formula. So S, and then we're going to say it's 6 terms. So S sub 6. Notice again, we're using this formula over here. S sub 6 equals A sub 1, which is 1/3, remember that's the first term, times 1 minus R is 1/3. So we're going to say 1/3 to the 6th power, all over 1 minus 1/3, because that's 1 minus R. So we're going to solve this, okay? And then we're going to end up getting our answer here. So the sum of the 6 terms here, 1/3 times 1 minus, and then 1/3 to the 6th power is 1 over 729. 1 minus 1/3 is 2/3. Okay, so now we're almost there. We just have to simplify this. And so remember, kind of like the keep, change, flip thing, we're going to be doing that with this fraction down here. We're also going to be figuring out what this is here. If you make a common denominator of 729, so this would be 729 over 729, that's what 1 whole is equal to, minus 1 over 729. It'll be nice and easy then for you to find the fraction anyway. I know this looks horrible, but... So the final step here, this is going to be 1/3 times 729 minus 729 over 729 minus 1 over 729 is 728 over 729. And then remember, keep, change, flip. So we're going to multiply by the reciprocal of 2/3, which is 3 over 2. We can cancel these 3's out. And then we can also reduce these right here because 2 can go into 728 364 times. So this reduces to a 1, this reduces to 364. And so our answer is 364 over 729. That's the sum of all of those terms, all 6 of those terms added together. That's quite an example, isn't it? So we're going to do an example 6, and that example writes the series a little bit differently. So this is example 6 in your book, and that particular one, it writes it using sigma notation, and you saw that in the beginning of the chapter 13, and it shows you different parts of this. You'll see when you look at this particular example, it says find the sum of the series, written like this. So again, this is a geometric series because we have the base here. That's going to be the common ratio. So when you identify these, here's your common ratio. Here's your first term, a sub 1. And then remember the index here, this tells you we start at 1 and then we go all the way to 12. So this is telling me we have 12 terms here. So n equals 12 in this case. If you start at 1 and go to 12, then you have 12 terms, okay? So we actually have everything we need for our sum. So we're saying S sub 12, we're finding the sum of 12 terms, and that's going to be equal to a sub 1, that's first, so that's 3. And then remember on the top we have 1 minus r to the nth power. So we're going to say 1 minus, and then r is negative 2, so you have to say negative 2. And then to the nth power, n is 12. All over 1 minus r, and again r is negative 2. So that's going to be what we write there. And this ends up being 3 times, if you were to put this in your calculator, this right here, you'd end up getting negative 4,095. And then on the bottom, 1 minus negative 2 is 1 plus 2, which is 3. Notice the 3's cancel. And then from there, the last thing is that the sum is negative 4,095. Okay? Hopefully you won't have difficult examples like for that first one. And on the next video, I'll do one more example maybe for you that's a little bit nicer. And we'll also talk about sums of infinite geometric series.